Thank you all for joining us this morning, and I just wanted to do a quick, I'm going to call it a chalk talk this morning, and share with you the formulas that we use, the mathematical formulas that we use as we think about developing materials for our kids. And so there are two formulas I want to share with you this morning. One is the formula, the variables that we need to think about to understand what makes up the kids we get mathematically in the classroom, and then the formula for getting kids to where we want them to be. So, unraveling the variables in the math learning formula. B plus I, and there's I sub 1 and I sub 2, plus F plus A, obviously you guys know this already, is the kids we get. So we'll walk through that formula with you and see how that works. Hopefully it's something that'll be helpful. So B is for the math we are born with. And so we are born to do math. It is in our genetic makeup to do math. When they look at kids and they do tests, we are born, we're able to subitize. Everybody know what subitizing is? Subitizing is the ability to recognize a quantity without counting. So at a glance, we as human beings, infants, are able to recognize the quantity up to about 3 or 4, and it varies from individual to individual. And if you look up subitizing, if you go to Google and type in subitizing, you'll actually find a cool little game you can do, and you can compete with chimps. Chimps are actually better at subitizing than we are. They can subitize up to about 6. So we're able to recognize quantity at a glance of small numbers. We're able to compare quantities. So infants, mammals, any mammal they've ever tested is able to tell the difference between a lot and a few. And you know that doing those comparisons gets harder as the ratio gets closer to 1 to 1. And you can actually go online and do a little test for yourself and to see how good you are at comparing quantities. This one right here, which one has more, the yellow or the blue? Yellow. And did you do that by, how many of you counted to do that? Because if you counted, it doesn't count. So on a flash, you're able to tell the difference. And they did a study with upper elementary kids, and the kids who were better at distinguishing which one had more, when the ratio was close to 1 to 1, actually when they looked at them, they had a history of higher performance in math going forward, and when they looked at them later, they were also higher math performers later on. Now, it's a correlation. Is it a cause and effect? Not sure. But this, again, is an ability that we have to do comparisons. We're born with this ability. We are primed to do math. We're also able to add and subtract. And so this is, if you go and, this is from a video in one of the baby labs that they have, where they take these poor little children and put them, wire them up, and there are little dolls in the back you can barely see in the corner there, and they do these little puppets, and kids are able to actually add and subtract up to 1, 2, and 3. They're surprised when they see 2 and there's 1 missing, and they know it was 1 that's missing. When they're 2 and then the dolls go behind a curtain, they're raised, and there are 3, they go, wait a minute, that's not right. So they have all these ways of testing. We can do add and subtract. When we're infants, we're ready to do that. There's even people who are looking and wondering that we actually are born to do fractions and ratios. So kids, for instance, when they see something on the edge of a table, and it's close to the edge, and it's like it should fall off, but it doesn't, and I won't let it fall. Some people are worried. They're like, wait a minute, that should fall. And it's probably one of the reasons why kids are always pushing things to the edge until they fall off and give you a mess to clean up. So they have these tests again, and that we seem to be able to recognize ratios or differences in ratios. So we have all these abilities we are born with. And I think it's important to understand that it's a variable, because we're not all born with the same ability to do these spatial comparisons, but we are all born to do math. And that's really important when you think about people who say, oh, I'm just not good at math. Hey, you were born good at math. So the question is, what do we do to add on that? And this is where, first starting with the I, our informal experiences then add to what we are born with. And actually, some of that starts prenatally. So there's I sub 1, which is the mathematical informal experiences we have, like counting. We do things like counting ducks or counting place settings. We do this stuff. The things you do at home with your kids when they're little has an impact on their number awareness and actually cognitive development. Playing board games. It's a great thing. There's great research out there that just playing board games with kids in preschool years has a big impact on their number knowledge and their ultimate success in math. They're rolling dice, they see patterns, they connect those patterns to numbers and distance, and that stuff is fabulous. We do creating sets. We're always organizing things. Kids are great at organizing things. That is a basic mathematical concept, particularly when it has to do with quantities, like everyone who's between the ages of 3 and 5. All right, so wait a minute. Now we have inequalities and domains and subsets. All that stuff that we're doing, again, is a mathematical concepts that we are doing informally in our lives. And we're also doing things where we're comparing relationships. We share. Kids who have siblings are very familiar with the concept of having H-A-V and having H-A-L-V-I-N-G. And so that kind of evenness, again, is a fractional concept that is in place for kids, almost all kids, of sharing and dividing things up equally, understanding that ratios. And those informal experiences help build. And again, it is different. It is a variable. And what you find is that kids who come from higher socioeconomic backgrounds have richer informal experiences in math, just as they have in reading. And that puts them at, I don't know if you want to say an advantage, but they now have had more cognitive work going on as they come into school than kids from lower socioeconomic backgrounds. And that's an important factor in understanding who these kids are, what explains the way we get them. And then there are informal experiences that aren't mathematical, that have a big impact on their ability to learn. Kids' ability to self-regulate. You guys know the marshmallow study? It was done many, many years ago, like in the 50s or 60s. 4-year-old kids, the guy put 2 marshmallows on the table for the kids and said, or 1 marshmallow, and said, I'll give you 2 marshmallows when I get back if you don't eat that one until I get back. And the kids who were able to wait, some up to 20 minutes, when they looked at those kids like 30 years later, those kids had more life success. They were able to self-regulate, and they did all these things like this. I'm not looking at the marshmallow. It's not there. They'd cover it up. But they had all these mechanisms for regulating their behavior. The other kids who, as soon as the person left, ate it, they were not as successful in life. Our ability to self-regulate, our ability to do to think through issues. There was just a study that came out that suggests that kids who grow up in bilingual households, who hear from at infant stages 2 different languages, are better able to have better executive function. They are better able to say, oh wait, I need to pay attention to this, I need to turn that off. They can adjust because they're hearing multiple inputs at the same time. Very early, rough study, but it just came out in the last week. But those kinds of things are important for all learning, including math. Stress. They call it chronic stress. Some people, the researchers call it toxic stress. Kids who grow up with nutrition deficits, whatever, those have an impact on your cognitive development, particularly on working memory. We're not all equal there. The way you grow up, even at prenatal stages, has an impact on your cognitive functions. That is part of the picture for the kids we get. So there's informal experiences, and then the formal ones. And these are the ones that you guys know. This is what we do. Formal experiences, formal instruction, and there's just a bunch of questions. Is that formal instruction built on the informal and innate abilities that the kids are bringing in? Are they connecting it to what they already know? Is it connected all together? Are we treating standards as little isolated bits disconnected from each other, or is it part of a coherent progression?